What is blockchain and how does it work? Blockchain is a decentralized digital ledger that securely records transaction data across many specialized computers on the network. Blockchain ensures data integrity through its immutable nature via cryptography and consensus mechanisms, meaning once information is recorded, it cannot be altered retroactively. Blockchain forms the backbone of cryptocurrencies like Bitcoin and Ethereum, and is instrumental in fostering transparency, security, and trust in various sectors beyond finance. What is blockchain? A blockchain is a special kind of database, also called a decentralized digital ledger, that's maintained by numerous computers distributed around the world. Blockchain data is organized into blocks, which are chronologically arranged and secured by cryptography. The earliest model of a blockchain was created in the early 1990s when computer scientist Stuart Haber and physicist W. Scott Stornetta employed cryptographic techniques in a chain of blocks as a way to secure digital documents from data tampering. Haber and Stornetta inspired the work of many other computer scientists and cryptography enthusiasts, eventually leading to the creation of the first cryptocurrency powered by blockchain technology, Bitcoin. Since then, adoption of blockchain technology has gradually widened, and cryptocurrencies are used by an increasing number of people globally. While blockchain technology is often used to record cryptocurrency transactions, it's suitable for recording many other types of digital data and can be applied to a wide range of use cases. What is decentralization in blockchain? Decentralization in blockchain refers to the idea that the control and decision-making power of a network is distributed among its users rather than controlled by a single entity, such as a government or corporation. This can be helpful in situations where people need to coordinate with strangers or where they want to ensure the security and integrity of their data. In a decentralized blockchain network, there's no central authority or intermediary that controls the flow of data or transactions. Instead, transactions are verified and recorded by a distributed network of computers that work together to maintain the integrity of the network. When people talk about blockchain technology, they're often not just talking about the database. Blockchain technology powers applications such as cryptocurrencies and non-fungible tokens, NFTs, allowing people to collaborate and transact with each other without relying on a central authority. How does blockchain work? At its core, a blockchain is a digital ledger that securely records transactions between two parties in a tamper-proof manner. These transaction data are recorded by a globally distributed network of special computers called nodes. When a user initiates a transaction, such as sending a certain amount of cryptocurrency to another user, that transaction is broadcast to the network. Each node authenticates the transaction by verifying digital signatures and other transaction data. Once the transaction is verified, it's added to a block along with other already verified transactions. Blocks are chained together using cryptographic methods, forming the blockchain. The process of verifying transactions and adding them to the blockchain is done through a consensus mechanism, a set of rules that govern how nodes on the network come to an agreement about the state of the blockchain and the validity of transactions. Cryptography is key for the blockchain to maintain a secure, transparent, and tamper-resistant record of transactions. For example, hashing is a crucial cryptographic method used in blockchains. It's a cryptographic process that converts an input of any size into a fixed-size string of characters. The hash functions used in blockchains are generally collision-resistant, meaning that the odds of finding two pieces of data that produce the same output are astronomically small. Another feature is called avalanche effect, referring to the phenomenon that any slight change in the input data would produce a drastically different output. Each block within a blockchain securely contains the hash of the preceding block, establishing a robust chain of blocks. Anyone wanting to alter one block would need to modify all the succeeding blocks, a task that is not only technically challenging but also prohibitively costly. Another cryptographic method widely used in blockchain is public key cryptography. Also called asymmetric cryptography, it helps establish secure and verifiable transactions between users. This is how it works. Each participant has a unique pair of keys, a private key, which they keep secret, and a public key, which is openly shared. When a user initiates a transaction, they sign it using their private key, creating a digital signature. Other users in the network can then verify the transaction's authenticity by applying the sender's public key to the digital signature. This approach ensures secure transactions because only the legitimate owner of the private key can authorize a transaction, but everyone can verify the signatures using the public key. Another feature of blockchain is its transparency. Anyone can generally check a blockchain's data, including all the transaction data and block data, on public blockchain sites. For example, you can see every transaction that's ever recorded on the Bitcoin network on Blockchain Explorer sites, including the sender and receiver's identifier, the amount of the transfer, and a list of owners of any Bitcoin. You can also trace the blocks from today, at block 788,995 as of 1852 and 21 seconds Greenwich Mean Time on May 29, 2023, all the way back to the first block, known as the Genesis block. What is a consensus mechanism? A consensus algorithm is a mechanism that allows users or machines to coordinate in a distributed setting. It needs to ensure that all agents in the system can agree on a single source of truth, even if some agents fail. They ensure that all nodes in the network have the same copy of the ledger, which contains a record of all transactions. Consensus mechanisms are necessary for blockchains because there is no central authority to verify transactions and maintain the integrity of the network. When tens of thousands of nodes keep a copy of the blockchain's data, some challenges can quickly arise, including data consistency and malicious nodes. To ensure the integrity of the blockchain, there are various consensus mechanisms that govern how network nodes reach an agreement. Let's now look into the major ones. Types of consensus mechanisms. What is proof of work? Proof of work, POW, is a consensus mechanism used in many blockchain networks to verify transactions and maintain the integrity of the blockchain. It's the original consensus mechanism used by Bitcoin. In POW, miners compete to solve a complex mathematical problem in order to add the next block to the blockchain. In the process known as mining, the first miner to solve the problem is rewarded with cryptocurrency. Miners must use powerful computers to solve mathematical problems to mine new coins and secure the network. This is why the mining process requires significant amounts of computational power and, therefore, energy. What is proof of stake? Proof of stake, POS, is a consensus mechanism designed to address some of the drawbacks of proof of work, POW. In a POS system, instead of miners competing to solve complex mathematical problems to validate transactions and add new blocks to the blockchain, validators are chosen based on the amount of cryptocurrency they stake in the network. Validators hold a certain amount of cryptocurrency as collateral, or stake, to participate in the consensus process. They are then randomly selected to create new blocks and validate transactions based on the size of their stake. Validators are rewarded with transaction fees for creating new blocks and as an incentive to act in the best interest of the network. Other popular consensus mechanisms. Proof of work and proof of stake are the most common consensus algorithms, but there are also others. Some are hybrids that combine elements from both systems, while others are different methods altogether. For example, delegated proof of stake, DPS, is similar to POS, but instead of all validators being eligible to create new blocks, token holders elect a smaller set of delegates to do so on their behalf. On the other hand, in proof of authority, POA, validators are identified by their reputation or identity rather than the amount of cryptocurrency they hold. Validators are selected based on their trustworthiness and can be removed from the network if they act maliciously. Benefits of blockchain. 1. Decentralization. The decentralized nature of blockchain means that there is no single point of control or failure, which can make it more secure and resistant to attacks or data breaches. 2. Transparency. Transactions on a blockchain are visible to all participants, making it easier to track and verify transactions and ensure their accuracy. 3. Immutability. Once a transaction is recorded on a blockchain, it cannot be altered or deleted. It creates a permanent record of all transactions that can be verified by anyone with access to the blockchain network. This is a significant departure from traditional systems where transactions are reversible. 4. Efficiency. Blockchain can enable faster and more efficient transactions because it doesn't require intermediaries, such as banks. 5. Lower fees. By eliminating intermediaries and automating processes, blockchain can reduce transaction costs and make certain business operations more efficient. 6. Trustlessness. Blockchain technology enables transparent transactions verified and validated by the network's participants themselves without trusted intermediaries. What are the different types of blockchain networks? Public blockchain. A public blockchain is a decentralized network that is open to anyone who wants to participate. These networks are typically open source, transparent, and permissionless, meaning that anyone can access and use them. Bitcoin and Ethereum are examples of public blockchains. Private blockchain. A private blockchain, as the name suggests, is a blockchain network that is not open to the public. Private blockchains are typically run by a single entity, such as a company, and are used for internal purposes and use cases. Private blockchains are permissioned environments with established rules that dictate who can see and write to the chain. They are not decentralized systems because there is a clear hierarchy of control. However, they can be distributed in that many nodes maintain a copy of the chain on their machines. Consortium blockchain. A consortium blockchain is a hybrid of public and private blockchains. In a consortium blockchain, multiple organizations come together to create a shared blockchain network that is jointly managed and governed. These networks can be either open or closed, depending on the needs of the consortium members. Instead of an open system where anyone can validate blocks, or a closed system where only a single entity designates block producers, a consortium chain sees a handful of equally powerful parties acting as validators. The rules of the system are flexible. Visibility of the chain can be limited to validators, visible to authorized individuals, or visible to all. If the validators can reach a consensus, changes can be easily implemented. As for how the blockchain works, if a certain threshold of these parties behave honestly, the system won't run into problems. What is blockchain used for? While blockchain technology is still in its infancy, it already has use cases in many different industries. Some of the most common current applications of blockchain technology include 1. Cryptocurrencies. Blockchain technology was developed to support the creation of cryptocurrencies, which use blockchain as a secure and decentralized ledger for recording transactions. 2. Digital identity. Blockchain can be used to create secure and tamper-proof digital identities that can be used to verify personal information and other sensitive data. This could become increasingly important as more of our personal information and assets move online. 3. Voting. By providing a decentralized, tamper-proof ledger of all votes cast, blockchain technology can be used to create a secure and transparent voting system that eliminates the possibility of voter fraud and ensures the integrity of the voting process. 4. Supply chain management. Blockchain technology can be used to create a ledger of all transactions within a supply chain. Each transaction can be recorded as a block on the blockchain, creating an immutable and transparent record of the entire supply chain process. 5. Smart contracts. Smart contracts are self-executing contracts that can be programmed to execute automatically when certain conditions are met. Blockchain technology enables the creation and execution of smart contracts in a secure and decentralized manner. One of the most promising applications of smart contracts is for decentralized applications, dApps, and organizations, DAOs. Closing thoughts. Blockchain technology offers a secure and transparent way to record transactions and store data. It has the potential to revolutionize industries by bringing a new level of trust and security to the digital world. Whether enabling peer-to-peer transactions, creating new forms of digital assets, or facilitating decentralized applications, blockchain technology opens up a world of possibilities. As the technology continues to evolve and gain wider adoption, we can expect more innovative and transformative use cases to emerge in the coming years.